Welcome to the LeetCode server. I am a LeetCode server. Today we are going to solve a 13th problem of 30-day LeetCoding challenge. And the problem name is Contiguous Array. Let me open the problem and we will solve this problem from the scratch. I will go through all the thinking process and solution idea generation and everything that we need to do in real coding challenge in interviews. So let's begin. Contiguous array. Given a binary array, okay, find the maximum length of the contiguous subarray with equal number of 0 and 1. 0 and 1 binary array. So binary array means, I mean, I think it tries to say that the array elements will be either 0 or 1. Yes, and we have to find the maximum length of the contiguous subarray with equal number of 0 and 1. So for here we can see 0 and 1. And length is 2 definitely because in this length there are equal numbers of 0 and 1. There are 1, 0, 1, 1. So 0, 1 is longest contiguous subarray with equal number of 0 and 1. Nice. And in this array, the answer is also 2 because but we can either take 0, 1 or we can either take 1, 0. The longest equal number of 0 and 1. The length of the given binary array will not exceed 50,000. Okay, nice. Well, so other example could be like 0, 0, 1, 1. Here the answer will be 4, and even if it is 1, answer will be 4 because we will pick this range, this contiguous subarray. The meaning contiguous here, I think the array elements should be in contiguous manner in their index. Like if it is 0 index, it is 1 index, 2 index, 3 index. So we cannot take something like if it is like this, we cannot take this 2 0 and this 2 1. We cannot take because this is not contiguous. And the 0, if the 0 here blocks this subarray to be contiguous. Okay, anyway, so I understand the problem. Now let's think about the solution. Okay, 0 and 1, either 0 and 1. Okay, it may start from like 0 0 0. So here this instead of length 4, if the array is like this, the answer will be length 6 because we have to take this one. Okay, all right. All right, so the way we can solve it, I mean, what I'm thinking right now is what about calculating a total number of zeros total contiguous zeros up to certain point, and total number of 0 and total number of ones up to certain points. I mean total number of contiguous values up to certain point. We can then every time checking whether the previous endpoint meet the requirement or not. So what I'm trying to say is like total number of same values uh, preparing an array with the property that up to ith index, what is the longest suffix which have same elements. Okay, so what I'm trying to say is for above array, like if it is 0, then it will say like up to 0 point, up to this index, what is the longest suffix, like what is the longest subarray ending to this position which have the same value. So the longest subarray ending to this 0th position having same value is of length 1, and if we go move here, then longest subarray ending to 1th position having the same value is 2, and same applies for, like when we go here, then we will understand better. So for this, the for 8th position, let me define index as well, 0 1 2, and this is the calculated value. So we are calculating this. Okay, so up to this point, the up to 2th index, what is the longest subarray ending to 2th index into the ending to 2nd index having the same value, which is here is 1, and if for another index, 3rd index, the longest suffix array ending up to this position is of length 2, because we see that 1 and 1 are valid one ending up to 3rd position, and which is also suffix to 3rd position, and the length is 2, and same applies here, the length will be 3 for 4th position. Alexa, stop. Okay, 4th position, and now 5th position is 0 again. So now we see that the longest subarray length will be 1, and if it is 0 again, we see that longest subarray length will be 2. If it is 0 again, 7, we see that longest subarray length will be 3. Now how it can help us to find the answer, it is based upon the fact that if it is 3 here, then this is the longest same element ending up to this position. Now in order to know that we can easily find out that if, before three elements, before these three elements, there was an element which is not equal to 0, so which is 1 definitely, because this is a binary array. So before third position, before three element, there was a element which is not equal to 0, which is 3. And now how we can calculate the answer? It's based upon the fact that if we know this 3 is the length, we will also uh, get to know that what was the length for 1 before that. So here we see we can easily get it from this array. This also tells us 3. So the how we can form the answer, then we can find out the answer by taking from each position, for each position of the array we can find out the answer by calculating the suppose this array is kind of calculation, pre calculation. So say pre-calculation of ith position, and whatever the value was there in that position. So um, pre-cal of current I minus pre-cal of I. So we have to consider these two things, like this thing, okay, and subtraction from 7 minus 3, which is 4, in fourth position. This is 3. So subtraction of both of these, so which leads to I minus precal I, which is 7 minus 3, and which is 4, and the value over here is also 3. So now how we can find the answer is like, if it was not 3, like if it was 2, then we cannot take 3 length in both sides. So in that case we had to take 2 length. So that's why we have to take the minimum value among them. So minimum value among them, and it should be multiplied by 2, because we will be considering both 0 and 1. So this will be our answer. For each position of the array, we will be having this as an answer ending up to that position. But in order to find the actual solution, to find the maximum length, this will give us the length ending up to that position. But in order to find the maximum length, we have to maximize above calculation for above calculation. Okay, we have to maximize above calculation. We will get the answer of the solution problem. Now what remains? The part that remains is like, what if we cannot get this value, like if we subtract this and this goes beyond the 0 index. Like for example, in this case we see that if we subtract 1 minus 2, it will goes out. In that case, definitely we will not be considering the answer. We will simply ignore that calculation. We will take 0 in this case. I mean, that would be good. So here we can see that we are iterating over the array, and we are calculating, forming this pre-calculation of the values, and we are maximizing, we are calculating the answer for each position, and we are maximizing the answer to get the maximum longest contiguous subarray having equal number of 0 and 1. Now what will be the time and space complexity of this solution? Definitely the time complexity would be big O of n, where n is the length of the array nums, and space complexity would also be the same. space complexity is also big O of n, because we are taking the calculation pre-cal array in order to calculate those values. Well, this is my first idea. Now let's implement this. Let's define a vector int pre-cal which is of same length with value say 0. Now let's define n, which is the size of okay, nums dot size. Okay, now for each value in the given array nums, we will be calculating pre-cal, so which is the contiguous value subsequence ending up to that position, contiguous value sequence ending up to that position. Let's define same value length is 0 initially. If I is 0, then same value length will be 1, and else if suppose nums of I is not equals to nums of I minus 1, so this is a transition phase. Suppose this there was 0 0 and it moves to 1, like from 0 to 1, transition phase. In this transition phase, nums of I is not equal to nums of 0. In this case, the same length value, whatever it was before, same value length will also be equal to 1. Now else, like what will be else the value will be same. So in this situation we will be having same value GTH will be incremented. Now we have this value, we have to put it over here, pre-cal of I, which is equals to same value and GTH length. Now if we found that I minus pre-cal of I, which is less than 0, in that case we won't be considering that. So let's define the global solution, which is our answer to the problem. So let's define answer, which we will be maximizing. Initially let's 0, and we will be calculating this only if we find that this value. So let's say if it is greater than or equals 0, then we will be calculating, otherwise we will be simply ignoring that. So we will try to maximize the answer with the global answer. And what is the current answer? Current answer is minimum of those into 2. So let's simply copy this, a minimum of pre-cal of I and pre-cal of I minus pre-cal of I multiplied by 2. Okay, so this bracket ends here and we multiplied by 2. Nice. Now we will simply return the answer to the problem. Okay, Let's go through the solution again. What we are doing initially, say for example for this array, uh, initially we calculate the length, which is 1 2 3 4 5 6 7 8 length, and we define a precal vector with the same length, and initially this is 0 and answer is also 0 initially, and we are iterating over the given array, nums array, and initially if I is 0, then definitely same value length will be 1, and if both are not same, then we are putting 1. Yeah, makes sense. Otherwise we are incrementing this. Okay, makes sense. Now what happens in this array case? So in this array case, initially it goes here, same length value is 1, and it goes here, and in 0th position it stores precal of I will be 1, and now it moves here, and you see that I, which is 0 minus precal of I, 0 minus 1, which is negative, so it will not meet the condition. Now it will goes to this position, second position, and it was 1 before, and it will go to the second position, and here it doesn't meet this condition, it doesn't meet this condition either, so it meets this condition, so it will be same length value will be incremented, and it will be 1, it will be 2, and then after it goes here and put it here, so it will be 1 2 precal array, and then after I minus precal of I, which is 1 minus 2, which is not greater than or equals to 0, so it will be ignored. Now it will move to third position. In third position there is 1, so it doesn't meet this condition, it met this condition, I minus num of I, so now same length value is 1, and precal of I is 1 now, and 1 minus 0 1 2 2 minus the position is 2, 2 minus 1, which is 1, so 1 is greater than equals to 0, so now it tries to maximize the answer. So initially answer was 0, and what it tries to do is it will try to maximize among 0 and minimum among the value in this and this position. So the minimum value among 1 and the minimum among 1 and I minus precal of I, which is this one, so which is 2, so minimum among them is 1 multiplied by 2, which gives us 2, and this is also valid because we are considering this 0 and 1 subarray, and this is also valid subarray having equal number of 0 and 1. We are considering that subarray and trying to maximize with our global answer, and we see that the maximum now will be updated, and answer will be now equals to 2. So let's update our answer, which is 2, and similarly it goes to another position, which is fourth position, 0 1 2 third position, third index, but fourth position, and in third index we see that it meets this condition and it becomes 2, so let's define it as 2, and we see that this is also 2 minus 3 minus 2, which is equals to 1, and it tries to maximize, and it found that we can maximize the answer, and now answer will be uh, considering both 2 and 2 and multiplying by 2, and answer will be 4, 2 multiplied by 2, so let's update our answer to be 4, and we will move to another position, and we see that this is also same value, and same value will be updated, and it will be now 3. And we go here and we try to do the same, and we try to maximize first of all minimize 2 and 3, which is 2, and maximize the answer, and answer will not be maximized because previous answer was 4, and the current answer is also 4, and it won't be updated, answer won't be updated. And now let's move to another position, which is 0, this position, which is 0, and we see that this is not equals to previous one 1, so it is 1, and now same value length will be 1, and it tries to maximize among 1 and 3. um, First of all minimize among 1 and 3, which is 1, and multiplied by 2, which is 2. So previous answer was 4, current answer trying to make it 2, so which considering this subarray, but which is lesser than previous one, so answer won't be updated. Now let's go to another value, which is 0, and same length value will be 2, and we see that it tries to minimize among 3 and 2, which is 2, and multiplied by 2, which is 4. So answer won't be updated because previously it was 4 as well. Now it will go to the last position, which is 0 again, and same length value will be incremented and it becomes 3, and now it tries to find the minimum among 3, and the 7 minus 3, which is fourth position, and it tries to it sees both of them are minimum among both of them is 3, and it tries to multiply 3 with 2, which will be 6, and previous answer was 4, so it will update our answer to 6. And finally whatever we get in answer variable is 6. So yeah, let's run the code. Compiles an error. Character 10. Okay, this was example. Let's comment out. Okay, let's try with the custom test case, which is our example we used. Okay, answer should be 6. Let's submit problem. Wrong answer. Okay, 0 1 0 1. Output is 2, expected 4. Okay, then I misunderstood the problem. This should not necessarily be contiguous. Okay, okay, 0 and 1 can be alternate. They can occur alternately. Okay, contiguous array with the value can be in any position. Like I was thinking that 0 and 0 will be together, and 1 and 1 will be together, or either 1 and 1 will be together, then after 0 and 0 will occur. Given the binary, find the maximum length of the contiguous array with equal number of 0 and 1. Okay, that's totally wrong. Anyway, we solve another problem, so we can think about another problem. Like we will be given an array, and we have to find a contiguous array subarray with equal number of 0 and 1. 0 and 1 should occur in the subarray contiguously. That is another problem. We solved it earlier. Now let's solve this problem with no requirement that 0 and 1 should occur contiguously. They may occur anywhere in the array. and the subarray length thus we are considering should have equal number of 0 and 1s. Okay, so in this case what I'm thinking right now is we will simply remove this code and yeah, this will be stored in my history anyway. I'll try it later. uh, I may make another problem statement. So let's consider the such cases like this 0 1 0 1 kind of things, and let's think about the solution. 0 1 0 1, so answer in this case will be 4. Okay, so what we realize in previous mistake is that we should not jump into the code. We have to clarify everything. We have to think about the corner cases and contiguous array with equal number of 0 and 1. We should not always consider the example input. We have to generate our own input. Before that, generating our own input, we need to understand the problem statement fully. Yes, like by looking at the example, thinking about the zeros will become 0 will be in the beginning, either 1 will be in the beginning and then after 0 will come. Like the definition of contiguous will not apply. I mean, it may be zigzag, either 0 1 0 1, and overall the equal number of 0 and 1 are required. Anyway, let's think about the cases. 0 1 0 1 and 1 0. Okay, the answer will be 6. Let's say 1. Now there should be equal number of 0 and 1, and so it doesn't matter the zeros and 1 are contiguous. Overall the 0 and 1 should be equal in a contiguous subarray. So that means if we consider this, it is valid, and if we consider this, it is also valid, and we can also consider 0 0. This is also valid case because it contains equal number of 0 and 1, and yeah, the overall the subarray is contiguous. The element shouldn't be should not be, I mean 0 and 1 should not be necessarily contiguous, but overall subarray is contiguous. Now what we can do is we can simply think about the number of I think number of 0 and number of 1s. If we consider this, like here we have total number of 0 is 1 and total number of 1 is total number of 0 is 1 and total number of 1 is 0, and here total number of 0 is 1 and total number of 1 is 1 in second position. In third position we see that total number of 0 is 2, total number of 1 is 1. Fourth position we see that total number of 2 and this is also 2, 1 is also 2. In fifth position we see that it is 2, total number of 0 is 2, total number of 1 is 3. In sixth position we see that total number of 0 is 3 and total number of 1 is also 3. And in another position we see that total number of 1 is 4. Now if the case was like this, then there will be little bit difference, like this is 1 and 0, this is 2 0, this is 2, this is 3, this is 3, this is 3, 4, 4. So answer here is 4 4. And here we see that in this position, if we think about this position where there is 3 ones and 3 zeros, both are 3 3. Now if we somehow subtract, I mean the case is not obvious, but here if we think about up to this position, the up to this position even, the answer is up to this position is 4. So this position refers to 3 2, 3 2, and 0 is 3 and 1 are 2. Now in order to meet this, the difference here is 0 minus 1 difference. If you see, 0 minus 1 difference here is 1, and in order to satisfy this, we need to have some index before. Okay, here we have 1 minus 1 0, which is difference is 1. So we see that difference here is 1 and this is also difference 1, which indicates that the if we subtract this from that, then we will get the same. Like if we subtract 3 minus 1, which is equal to 2, and if we subtract 2 minus 0, which is equal to 2. So overall this situation tell us that the overall values within that range will be equals. Well, so let's apply our thinking into coding, how we can implement this. Let's store only difference, maybe 0 minus 1. So here it is 1, it is 2, it is 1, it is 2 again, it is 1 again, it's 0 again, it's 1 again, it's 0 again. So in every one we subtract the 1. So here we see we get the actual subarray. So every one, the difference here, if we subtract this, we will get the uh, actual subarray with equal number of zeros and 1. So for this we can use a hash map to store the, for every difference we will try to maximize the length. That's why we will try to store the index if we have not stored it before, so that it will be as left as possible has the index for the difference, and whenever we get this difference we'll try to find that index and we'll try to subtract that. Now for the 0 case we can consider there is another values over here so that we can get the full length if it is 0, like the length starting from the beginning, because this is a valid and there is no any previous difference recorded. Alexa, stop. So in this way we can formulate. So let's define another map with the integer, say hash map, and let's try to iterate over the array. And let's define difference. Diff is 0. So if nums is equals 0, diff plus plus. If we find 1, then we'll subtract. So diff minus minus. And if hash map do not has this value before, hash map dot count diff. If hash map do not has this value before, then we'll store the value. Hash map of diff will be equals to this position, and let's initialize the hash map of 0 will be equals previous position, which is -1, previous position, previous index. And yeah, if it is occurring for the first time, we are storing this, otherwise we will be calculating the answer. So let's calculate the answer and tries to maximize the answer. Answer equals 0. Maximum of answer of hash map of diff, actually I minus hash map of diff, which is our answer. Okay, let's try to run. Nice. Let's try with this case. Four. Okay. Let's try with the case we are considering. It should also give us. It should give us actually 8. Awesome. Let's submit the problem. Accepted. Nice. So yes, let's define the time and space complexity. The time complexity for this problem is big of n, and space complexity is also big of n, because the time complexity here is we are iterating over the array, and for the n times, and space complexity is big of n because we are taking consideration of hash map, which are storing which is storing n values overall, and in worst case, I mean, and that's why it is big of n for space complexity, and for time complexity big of n because we are iterating only n loops. Yes, this is my solution to the problem. Maybe there could be more optimized solution in the sense of space complexity, and yes, If you have any solutions which is more optimized than this in sense of space complexity, please feel free to share and comment. Yes, thank you so much, and yeah, wish you all the best.